Hello friends, we are discussing in this video regarding inductive effect and electromeric effects. Generally, inductive effect and electromeric effect involved in the reactions. The prepared by Mr. Narayan Pawar, Department of Pharmaceutical Chemistry at Sri Prakashan Jain, College of Pharmacy and Research at Plastoid. So, we start regarding inductive effects. Generally, inductive effects are defined as the definition of inductive effects, the polarization of sigma bond. Sigma bonds means also covalent bonds. The polarization of sigma bond due to electron withdrawing or electron donating effect of adjacent groups or atoms is called as inductive effects. Inductive effects means the polarization of sigma bonds due to electron withdrawing or electron donating effect. Why polarization of sigma bond or covalent bond generally happens? Because the atoms, adjacent groups or atoms are having the properties electron, either it will be electron withdraw or electron donates. If the group are attached to each other, they electron withdraw or electron donates to produce a polarization. The polarization of sigma bond or covalent bond, it is nothing but has a inductive effect. It means the example of this methyl chloride or chloromethyl. In that, these bonds are covalent bond. Covalent bond generally formed by the two electrons. Generally, each bond formed by a two electron or electron pairs. In that, covalent bond are produced by two sigma electrons. Two sigma electrons, one of sigma electron from the methyl group and one of the sigma electron from chloride atoms. In that, the methyl group containing sigma electrons are shifted towards the chlorine atoms. Because the chlorine atoms are more electronegative. These chlorine atoms are more electronegative. Its electron withdrawing properties. Its withdraw electrons means these electrons are, this one electron are shifted towards the chlorine atoms. These electrons are shifted towards chlorine atoms and it produce a polarized this sigma bond. This is a sigma bond or covalent bond. In that, the sigma electron of this covalent bond are shifted towards the chlorine atoms and chlorine get a partially negative charge. Why it's get a partial negative charge? Because it's reach the electrons, and methyl group are a partially negative charge because it's deficient of electrons. It loses their electrons towards a chlorine. That's why methyl are produce a partial positive charge or partial sigma, partial delta 1. Then the next, also inductive effects also defined as It is defined as a permanent displacement of a shared electron pairs. Means permanent displacement of permanently shared pair electron pair in carbon chain towards more electronegative atoms or group is called as a inductive effects. The definition of inductive effects is it is defined as permanent displacement of shared electron pair in carbon chain towards more electronegative atoms or group is called as inductive effect. In that the example, the chlorine atom are more electronegative, means the electron pair or share electron displaced towards the chlorines, because chlorine are a more electronegative atoms, and it is called as a inductive effect. So you been clear about why this happen, because the atom are attached, the adjacent atom are electron withdrawing or electron donating. That's why inductive effects are occurs. Then next, the inductive effects involves a sigma electrons. Only it is involved in a sigma electrons. Then this is the methyl chloride. In that this bond is a covalent bond, or it is made up by the sigma electrons. The next point of the inductive effect, the sigma electron which form a covalent bonds. We already said about sigma bonds form a covalent bond. Two sigma electrons form a one covalent bond, are shared equally between the two atoms. Are shared equally between the two atoms means the formation of this covalent bond are made up by the two sigma electrons, and generally these are two sigma electrons are equally shared between two atoms, means one sigma electron from methyl and one sigma electron from chlorine. Then next, the inductive effect, it's also written as a I effect. It refers to the polarity produced in a molecule as a result of higher electronegativity of one atom compared to another. Means the polarity produced in the molecule because of the one of the atom having a high electronegative than the other comparing to the another. Means it is the requirement is the compound or molecules having of they are containing of one of the atom or groups are more electronegative than the other. Then and thence the inductive effects are happen. Then this is because the inductive effect, this is because different atoms have a different electronegativity values. Different atoms having a different electronegativity values. That's why inductive effects are happens. Chlorine atom having a more electronegative value than a methyl group. This introduces a certain degree of polarity in the bond. Because of the different electronegative value produces a polarity of certain degree of polarity in the bonds. Then next, the more electronegative atoms acquires a small negative charge. The more electronegative atom acquires a small negative charge or also partial negative charge. Means chlorine having a more, in that the example of methyl chloride, the chlorine are more electronegative atoms. It acquires a partial negative charge, and the less electronegative atoms acquires a small positive charge. The example of methyl group are less electronegative than the chlorine atoms. It means methyl group possesses a partial positive charge. This one. Then the next, the inductive effect of carbon number 3 upon carbon number 2 is significantly less than the effect of chlorine atom on a carbon number 1. Then the inductive effect of chlorine atom on carbon number 1 is higher than the carbon number 3 upon carbon number 2. Means in that the chlorine atom are electronegative. It produces a polarity in these molecules. The chlorine atoms produce or inductive effects are produced in the carbon number 1, and chlorine atom is more than the carbon number 2 and chlorine atoms. It means the inductive effect of carbon number 3 upon carbon number 2 is significantly less. Here the inductive effects are less than the carbon number 1. The effect of chlorine is generally higher in the carbon number 1. This means the inductive effects, it is a distance dependence. It means the higher the distance of the atom are possesses from chlorine atom or electronegative atoms, decreases the inductive effects. Means it is a distance dependent effects. Generally inductive effects are distance dependent. Then the types of inductive effects, there are two types. First, electron withdrawing, or it is also called as a electron attracting inductive effects. Electron withdrawing or electron attracting inductive effects. It is written as a negative I effect. The definition of electron withdrawing inductive effects or negative I effects is those atoms or groups which withdraw electrons away from another atoms. Withdraw electrons away from another atoms are said to be a negative I effects or electron withdrawing inductive effects. This means those atoms or groups which withdraw electrons away from the another atoms are said to be a electron withdrawing inductive effect or negative I effect. The example of that atoms or groups: fluorine, chlorine, bromine, iodine, hydroxide and amine. These groups are electron withdrawing. These groups are produce a negative I effect or electron withdrawing inductive effects. Then the second type of inductive effect is electron releasing or electron donating or also electron losing inductive effects. It's also written as a positive I effects. Second types of inductive effects is electron releasing inductive effect. The definition of electron releasing effects: those atoms or groups which lost electrons towards another atoms are said to be a positive I effects. It means those atoms or groups which lost or donate electrons towards another atoms are said to be a electron releasing or electron donating or positive I effects. The example of electron releasing or electron donating inductive effects are the or positive I effects. The example is methyl, ethyl, isopropyl and tertiary butyl. These are the example of positive I effect or electron releasing inductive effects. Then the some points should be revised. The first, what is inductive effect? Inductive effects generally the shifting of electrons in covalent bond from low electronegative atom to high electronegative atom. We generally see before what is meant by inductive effects. Inductive effects nothing but the shifting of electrons in covalent bond from low electronegative atom to high electronegative atom. Then the second revised point is the always sigma electrons are displaced. It means inductive effects happens in generally a covalent bond or a sigma electrons. It is only occurs in a single bonds. It is happen in a inductive effects happen in a single bond. Then the third point, it is a permanent effect. Inductive effects are permanent effects. So here inductive effects are finished. Then next one effect is electromeric effects. Next effect is electromeric effect. Generally inductive effect and electromeric effects, why we are studying? Because the electromeric effect and inductive effects are involved in the reaction. That's why we are studying the inductive effect and electromeric effects. So let's start electromeric effects. Electromeric effects, definition of electromeric effects. The electromeric effects, it is written as a capital E effects or electromeric effects, refers to the polarity produced in a multiple bonded compound as it is approached by a reagent. It means the electromeric effects are polarity produced in multiple bonded compound. Generally polarity produced in a multiple bonded compounds. When and when? Because approaches the reagents. It means generally electromeric effects happens in presence of reagents, or it is happening in the multiple bonded compounds. In the electromeric effect, the polarity produced in a multiple bonded compound approached by a reagent. The example of the electromeric effects is ethene, molecule of ethene. Ethene having a 2 carbon atoms. In that, the ethene having a double bonds. Means electromeric effect having the or polarity produced in a multiple bonded compounds, means more than one bond. The compound having more than one bond. This is this pi bond are formed from a 2 far electron are shipped to this one methyl or carbon groups in the presence of attacking reagent. In the presence of attacking reagent. Here these groups are, both of the pi electrons are shifted on this carbon. These carbons are a negative charge because it is a electron rich. It produces a electron rich, and this one is a electron deficient, because this electron of this carbon are displaced or transferred on these carbons, means the lone pair of electron or 2 pi bonds pair of electrons of these pi bonds are shifted on these carbons, means these carbons are electron rich and this is a electron deficient. That's why this produces a positive and this one carbon produces a negative charge. Ethene are symmetrical molecules. In the symmetrical molecules, the electron of pi bond are displaced in the both sides, either this one sides or either this one sides, because the ethene molecules are the symmetricals. If the pi bond containing pair of electrons shifted on this one carbons, it is produce a negative charge because of its have a electron rich and this one a electron deficient, which means electromeric effects involving the multiple bonded compounds, approaches by attacking reagent or generally present of reagents. It means if the molecules are symmetricals, means pi bond are shifted in both of the sides. Then when a double or triple bond is exposed to an attacking, when a double or triple bond is exposed to an attacking by a reagent, means double or triple bond compound are exposed in the reagent, the 2 pi electrons which form a pi bond, means pi bond are formed from 2 electrons are completely transferred to one atom or the other atoms, means these 2 pi electrons of pi bond are completely transferred either this one carbon either this one carbon, but in the symmetrical carbons generally the electrons pair transferred both of the sides. Which means when double or triple bond is exposed in the attacking by a reagent, the 2 pi electrons of the pi bond are completely transferred to the one of the atoms. Then in case of asymmetrical atoms, acetone and propene are asymmetrical atoms. In this, the pi electron or pair of pi electrons are shifted from the lower electronegative atoms. The lower electronegative atoms are carbon, means the pair of pi electrons completely transfer on towards the higher electronegative atoms. Here oxygen are higher electronegative atoms, means this pi bond are shifted on the oxygen. It produces a negative charge. Oxygen are produce electron rich and carbons having the electron deficient. Same case in propene. Here are the electron donating group are present, methyl groups. That's why the pi bond of this propene, the electron pair of pi bond is shifted on this one carbons, not to this one carbon, because of this one the propene are the asymmetric and it produces a negative charge or electron rich carbon. This one is electron deficient. Then there are two types of electromeric effects. The first, positive E effects. There are two types of electromeric effects. First one is a positive E effects. The definition of positive effects: if electron pair shifted towards the side where attacking reagent to the attach, means electron pair shifted towards the side where the attacking reagent to attach, means the electron pair of 5 watt are shifted towards the attacking reagent attacking sites. Example, here the electron pair are shifted on this one carbon, and the attacking reagent protons are also attack on this one carbon, means the pair of electrons shifted side where the attacking reagent to be attached, means attacking reagent attack on this sides, and electron pair of these 5 bond are shifted on same atoms. That's why this is a positive E effect or positive electromeric effects. So these carbons are electron deficient, it produces a positive charge, and these pi electrons are shared with attacking reagent proton hydrogen to form a new bond, and these are the CH methyl. Same second example, in the acetone react with attacking reagent, in that this one pi bond of electron, pair of electrons shifted on oxygen, because oxygen are a more electronegative atom than a carbon atom, and the attacking reagents are attached on the oxygen. Attacking reagent of hydrogen or proton are attached on the oxygen, and the shifting of this pair of electron on a oxygen, it is a positive E effects. So I think everyone should be clear the definition of positive effect and example. If the electron pair shifted toward the site where attacking reagent to be attached. Then the negative E effects or negative electromeric effects. The definition: if electron pair shifted away from the site where attacking reagent to be attached. The electron pair shifted away from the site where attacking reagent to be attached. Example, that the hydroxide ion or attacking reagent attach on this carbon number 2. This carbon attaching the attacking reagent on the attack on this one carbon number 2, and the electron pair shifted towards this carbon number 1, means as per definition, electron pair shifted away from the site where attacking reagent to be attached. This attacking reagent are attached. That's why the producing of this one ion and this carbon are a electron rich, because the pair of electron of pi bond are shifted on carbon number 1. It produces a negative charge, means negative effects produces a negative charge of the compound, and positive effects produces of the positive charge on the producing compound. The second example, attacking reagent cyanides attack on carbon, and the pi electron pair of pi electron are shifted on oxygen. The oxygen produces a negative charge. As per definition, cyanide attack on the different side by the attacking reagent, by the shifting pi electrons, means attacking reagent attack on a carbon and this pi electron attack on this carbon. Then the uses of electromeric effects. Electromeric effects generally occurs in the different reactions happening, or generally electromeric effects are involved in the reaction happening. In that, acetonitrile and water molecules, where in that the water molecule containing a hydrogen have a positive charge species and hydroxide ion are a negative charge species. In that, the acetonitrile react with water molecule to produce a acidomeric acid. In that, this CN containing triple bond of this bond of 5 electron pair are shifted on nitrogen. After the shifting nitrogen, this hydrogen are attached to nitrogen by sharing this pair of electron to a hydrogen deficient electron of hydrogen to form a new bond NH. And this carbon of this electron are shifted on this one nitrogen, and it produces a positive charge or electron deficient, but the hydroxide ion, oxygen or electron, this bond electron are abstracted towards this. It gives a negative charge and it form a new bond with a carbon, produce a carbon hydroxide or carbon oxygen new bond to produce acidomeric acid. The second example, prop 1 in this one carbon number 1, carbon number 2 and carbon number 3. 3 carbon circuit containing propane, double bonds propane, react with hydrogen cyanide, hydrogen having the positive charge and cyanide having the negative charge, because the nitrogen having the electronegative or electron withdrawing properties. That's why the CH2 are these pi bonds are shifted on this one carbons, carbon number 1. The carbon number 1 reaches the electron because this electron pair shifted on this carbon and deficient of this hydrogen to form a new bond, that is CH3, and cyanide containing negative because of this bond are abstracted the electron, the form of new bond CN. The compound is a isobutyronitriles. Same third example, propane 2,1. In that same, these 5 bonds are shifted on oxygen, then the positive charge of hydrogens are attack on this oxygen to form a hydroxide OH bond, and Cn negative charge on this side. The positive carbon produces a Cn, the producing the product 2-hydroxy 2-methyl, 2-hydroxy 2-methyl propane nitriles. This is 1, 2, 3, means 2-hydroxy 2-methyl propane 1, 2, 3 propane nitrile. The product produces 2-hydroxy 2-methyl propane. Then some revision summary of the electromeric effects. Electromeric effects are temporary effects. Electromeric effects are temporary effects because it's observed, electromeric effects are observed only in the reaction happening. It is a electromeric effect are temporary effects. Second, it involves the pi electrons. In the electromeric effects, generally pi electrons are involved. Third, displacement of pi electrons only. In the electromeric effects, the displacement of generally pi electrons only occurs in presence of attacking region. Here the electromeric effects are generally presence of attacking region. This is a electromeric effect and inductive effect. In case of inductive effect, it is a permanent effect. Inductive effect are permanent effect, and in case of inductive effects, the sigma electrons are involved. Displacement of pi electrons only. Here is the displacement. Here displacement of sigma electrons or shifting of sigma electrons generally. Then presence of, in case of electromeric effects, the presence of attacking reagent. Generally it's happen on the presence of attacking reagent, but the inductive effect happen the presence of differentiating the electronegativity activity. Their electronegativity activity means the compound having both of the adjacent having one of the more electronegative than the second. Means everyone clear about the electromeric effect and inductive effects. There are some differences. So guys, here thank you so much. We will finish these topics, electromeric effect and inductive effects.